Okay, I'll get started on the pay to key stuff then. So the pay to key is a software that we developed at a hackathon a few months ago, and we just kind of touched it up. We didn't actually realize that anybody would actually be interested in the technology. It was just like we were building. Our thing was just we were going to build like Bitcoin on EOS was our idea. So we're like, hey, what if we wanted to just build like a relaying system onto EOS that could take Bitcoin addresses or EOS, like just EOS public keys, and you could send EOS to it. So we started with that premise. We built it out. We talked to Larimer after a while, and he was really interested in the idea for some reason, more interested than we were even. So he asked us to actually put it together into a proper module and release it. So we did that like earlier this week. And I guess now I kind of get it. Now that he's explained what exactly you can do with it, it makes a lot of sense. So the idea is that right now you need an EOS account to receive EOS. This will make it so you don't need one. You can just generate a key. You don't need to register the key on the chain or anything. It can just exist, and anybody can send EOS to that key. But what it also enables is it enables the ability for dApps to pay for people's CPU. So the reason is that normally right now, you have to have an account to make a transaction. You have to have an account to have EOS. So the account that sends the transaction, which has all the authorizations, has to be the one that pays for CPU. I think maybe with 1.8, we're finally changing that. I don't actually know. I haven't looked into the details of the hard fork. The Block 1 team just released 1.8, EOS 1.8, which is a consensus breaking release. So I think they've included a bunch of changes that they've been holding off on for almost a year. So I'm interested to look into that and see what's in there. But the ability for dApps to pay, so what you can do is there's a relayer that's separate from the person now that sends the actual EOS. So I can send EOS, but not be the one that actually relays that transaction. Somebody else could relay the transaction. So a dApp, for instance, could be the one that relays that transaction. And this is what we're going to do with Everpedia pretty soon, is we're going to have the ability, so you can send a vote or send IQ with this UTX with a public key. And we will relay the transaction on your behalf. And instead of taking a fee like a normal relayer would do to account for the CPU and RAM costs, we're just going to subsidize the CPU and RAM costs because we want you to use our app. So this allows, it's a way for dApps to be able to pay for both CPU and RAM on behalf of the user. Yeah, not even RAM as much, mainly it's the CPU portion. So basically you can pay for CPU on behalf of the user now. So users no longer have to worry about CPU. They can just sign a transaction and use this system to interact with an app. So you no longer need scatter to do it. So we're going to set this whole thing up so it's just, you have a key, we'll save it to local storage, like a private key. It'll be like a key where we tell you not to store too much IQ or anything. It'll be just for the Everpedia site. And so you'll have like an actual like proper key if you want to invest in IQ and hold larger amounts. We would tell you to have a separate key or have an account. But just for the Everpedia site, we'll set it up so that you can have this key that's loaded into local storage. And every time you want to sign a transaction, it automatically signs it in the background, and you have no idea that you just interacted with the blockchain. So all you see is like Stack Overflow or something where you see the amount of points you have in the corner, and you're like, oh, okay, I have a bunch of points. It's going to be like that. You're going to have a bunch of IQ. It's going to show up in the corner. But you're not going to realize at any point that you're interacting with the EOS chain, because everything's going to happen instantaneously in the background. And it's like, we're going to assume the transaction gets relayed, so we're not going to wait for it to be included in a block or anything. So it'll be like 1/200 second, just whatever the latency is to hit the server and come back, it's going to be how long it takes. So it's going to be just like any standard web request. And it's like the first step towards making, I don't think there's any other blockchain that does this right now, where, so Ethereum, when you use your keys, you have to pay a gas fee. And that gas is like one of the most annoying things to compute, to figure out exactly what the gas fee you should place is. Even for BTC, when you decide what fee you're placing, it's, you're kind of running a mental calculation in your head of like, how long do I want this to take, and etc. For me, when I run an Ethereum transaction, I go and I check each gas station every time. And I go above the fast one, like 1 or 2 gig away, just so I can make sure my transaction goes through immediately. All that calculation gets taken out here. You get the same feeless stuff that you get with EOS, but now you don't need an account as well, which is like the major barrier we have to EOS adoption. So we're hoping this key system turns into like the default way for smaller, what I would say is web apps that don't require insane amounts of security. Like Everpedia, some people want total anonymity or total security when they're doing this stuff. But most people just want to submit and edit. They don't really care about the censorship resistance of EOS as they're submitting the edit. So for dApps that are more like us, we're hoping this becomes kind of like the de facto way. And we're going to build out a library and stuff on top of this that allows dApps to make it a little bit easier to use. We're hoping this becomes like the de facto way for them to interact with the chain, and that there's tons of chain interactions happening with users that don't even realize that they're actually. So even like the key generation, we're not even going to generate the keys. We're not even going to tell the users really what their keys are. We're gonna have the option for you to export the key at any point. But when you first log in, we're just going to generate a key for you and store it in local storage in the background. We want you to not even know what a blockchain is and be able to use the site. So that's the goal with a lot of this stuff. Yeah, I don't know if anybody has any questions about it. That's all we really have to say about it for now. Oh, actually, there's one more thing. We're adding support. So the version we released a couple days ago was a demo that was specifically for the IQ token. It was missing some critical features like a replay protection. So if you're trying to play your own version of that right now, and you run a transaction on it, I'll be able to replay it on the IQ version. So that's something we really need to fix right off the bat. So that's in development like yesterday. By tomorrow we should have the replay protection out. And we're also adding the ability so right now it only handles IQ. We're going to make it a general contract where people don't have to deploy their own version of the UTXO, but anybody can just, the way you deposit tokens into the UTXO system right now, into the pay to key system, is you just send the EOS transaction with your public key as the memo. And we're going to enable that for all tokens. So any tokens that want to have that support are just going to be able to send just like you do EOSIO token create, you can run a UTXO token create in our smart contract itself. And you'll be able to use our namespace, you'll have your own little chain ID and stuff. We'll set you up with your own scope, and you'll be able to run your own version of the UTXO for your token without actually deploying a contract or anything like that. So what the EOSIO.token thing was supposed to be, but with UTXO.
Kedar, question. What happens when a user sends a transaction this way, but screws up how they input the public key?
So they send it to the wrong public key?
Yeah, they send to a malformed one or one that doesn't exist, and now you have this stuck transaction.
Right. It should be really difficult to do that. We're running checksums to make sure that the keys are valid. We're doing like every check that you would have on the traditional EOS system, we're running those same checks on these keys. So for you to malform a key in a way that the checksum comes out properly, that just means you got scammed. I don't think it's really it's a natural thing for you to be able to do that.
Yeah, okay. I didn't realize you were running checks and all that. And if I lose the private key associated to the public key?
I believe you're screwed. We're gonna take the contract and we're gonna multi-sig it to the BP prods minor, so APPs. Maybe if you convince APPs that your key could be changed, you could do that. Even that sounds like kind of a security flaw to me. So we might even, once it gets more and more stable, we might multi-sig it to like whatever the middle one is that requires like 11 per day.
Major.
Or,
yeah, I think,
yeah, we'll probably do that. So I mean, you're basically just out of luck if you lose the private key. It'll be like Ethereum.
Yeah, it makes sense. Just double check.
You got Orchid on. How's it going, Orchid?
Hey, yeah, nice to see you. And I actually got a question. Thank you for the explanation, by the way. Let's say if user wants to make a transaction and then they don't want to disclose their account so that they want to use UTXO address for escrow, let's say. In that case, one user can make that UTXO account, and then the other user who wants to send his or her EOS can just send it to the UTXO address. But then it's kind of similar to normal EOS account transactions, right? What would be the major difference in that situation?
I guess I'm a little bit confused. What's the use case?
Okay, so user A and B wants to do escrow.
Okay, that's good.
Yeah, and then there's UTXO address provider.
Mm-hmm.
So if, let's say that's just a DApp,
Okay.
and then user A and B so user A wants to send EOS to user B. In that case, he or she can just send their EOS from their exchange, let's say, to that UTXO address. Is that correct? Is that be possible?
It would be if the exchanges support a withdrawal to a key. That would be possible.
Okay, if they do not support, then there's no way users can send their EOS to UTXO.
You know what? We could probably figure out a way to do that. Actually, no, I take it back. It is possible. Yeah, you can deposit directly because you send it to that contract, and you in the memo field you put the key you want to send it to. Yeah, so you can withdraw directly to a key now. Yeah.
Oh, okay. Wow.
So you don't,
that
yeah, you don't need to. Yep.
Okay, that would be substantial for users, especially exchange users, to use any dApps or just yeah.
Yeah.
Because at some point we were thinking about escrow, making escrow, but smart contract, and then yeah.
Okay. So one more thing we're thinking about adding to this is like Bitcoin has end time lock, which I think is what you need to implement Lightning. Is there anything else besides that required for Lightning? I think it's just the end time lock one. Once we add end time lock to this, we'll in theory be able to use Lightning on this contract. So you'll be able to run, not just the scalability of having the EOS stuff, but also Lightning on top of it and state channels. Maybe not Lightning, you'll have state channels.
Oh wow, that's interesting.
Yeah, and actually one of the other things where somebody requested this, can't say who I guess for now, but somebody's requested this, and they want us to put they want us to, instead of having EOS public keys, the private keys are exactly the same for both EOS and Bitcoin. They use the same elliptic curve and everything. So the only difference between an EOS public address right now and a Bitcoin public address is the hashing and the encoding scheme used on the public key. So we can easily have a version of the contract, at least not change it, but we'll have a fork of the contract that uses Bitcoin addresses instead of EOS addresses. And at that point, we do have it in our roadmap to build like a Bitcoin relay, just like BTC relay exists on Ethereum, like a trustless swap method to move Bitcoin into the EOS chain. And once we do that, we intend on running EOS as a Bitcoin layer 2. So we're experimenting with the idea of, instead of having Lightning as the layer 2, having EOS itself be the layer 2 for Bitcoin. And it wouldn't just be EOS, it would be any EOS-based chain. So BOS, Warbly, what are the other ones we're looking at? Telos.
Oh wow, that would be substantial.
Yeah, so that's kind of the goal we're moving to, is trying to have EOS become the layer 2 for Bitcoin. And then on top of that, you could run Lightning on this as well.
Oh wow. So how can users make a key? Is it similar to EOS, creating an EOS account?
Yeah, you just run the create key. So when you generate keys, when you create an account, you just stop at that step where you generate the keys and you don't actually create the account.
Okay. Then users have to manage their keys just the same.
Yeah, that part, same as always. I guess you could take that upon yourself.
Yeah, you cannot. Yeah.
What we intend to do is we're going to store the private keys into browsers. We're just going to have the whatever browser you use stored into local storage, have it just stored away there. The cross-origin stuff should protect other sites from being able to access it. That's it. Yeah.
Okay.
And we're going to tell people don't store too much in there, so that in case you do with your browser stuff, then you don't lose access to your tokens.
Yeah, but I kind of worry that users wouldn't actually realize the difference between the two key systems, and they would actually recognize UTXO address to be more, safer.
Yeah, I guess, for users.
Better of conception. Yeah.
I guess that could be a problem. It is better to have an EOS account, definitely. I guess this is more like We see it like a gateway. We don't really want people to store large amounts of money,
Mm-hmm.
just small amounts.
Yeah, makes sense.
Cool. I mean, that's all I've got for today for this call. Do you guys have anything else that you guys are working on that you want to talk about?
You said it's going to be implemented on every PDA soon enough?
It's going to be a while. It's not going to be that soon. It's gonna be like
Okay.
5.
Okay.
Yeah, first, because we're going to build a bunch of infrastructure out around it. We're more concerned about building the infrastructure at the moment than getting it to a level where dApps can use it.
Mm-hmm.
So we'll add all this
Okay.
like Lightning, and we're even looking into, we're trying to see, this one's kind of still up in the air. We're trying to see if we can run like Mimblewimble style, like confidential transactions on this so that you can have basically zero knowledge transactions running, where you're completely private transactions where the amount is not known and the receivers are not known.
Yeah.
That would be really cool. But that's
Yeah,
really
of
up in
course.
the air. We have no idea whether we can possibly do that.
Is it on the roadmap as well?
It is on the roadmap, but like that one's like a total, we have zero idea whether it's possible or not.
Okay.
Yeah.
Okay.
Cool. You got
Thank you
anything
for
want to talk
building it.
Yeah.
Pardon?
about? Yeah. No, I was going to ask Josh if he has anything he wants to bring up before we end the call.
Okay.
I guess just to bring some awareness in case anyone doesn't know yet about the what we're calling EEP6, so EOS Enhancement Proposal 6, which is our proposal to try and generate something for connecting multiple chains. Basically having the mainnet be a hub for many different chains, figuring out there's still a lot of need to clarify things. So that's why it's kind of in a request for comment phase right now.
Cool. We'll include a link to that when we post this thing out. It's under the EOS Canada repo, right?
Yeah. I'll shoot you links.
I guess that's all we've got. Thanks for joining us on the EOS Town Hall. We'll have this video up tomorrow, I believe. See you guys next week.